Hello and welcome to an Algebra 2 video where we go through the notes this time about graphing trigonometric functions. What exactly are they going to look like and how can I make life easier if I have to produce a graph by hand? Oh no, the dreaded thing, how to put pencil on paper. Oh my goodness. Okay, first let's get the obvious out of the way. Yes, in this day and age, clearly you can use your graphing calculator, you can use Desmos or some other application to create a graph, push of a few buttons very quickly, much more accurately. So really, this should be about not graphing trig functions necessarily, but more like sketching, right? That's what I'm going to be covering here. How can you create a quick picture that gives you an idea of the key points for a trig graph quickly and easily? Well, we're going to need a few key components. We're going to want exactly what they're asking you to find, the amplitude and the period. That's it. If you know what type of trig function it is, you know its amplitude, you know its period, you can put together a real quick picture in a matter of seconds, okay? So here's what we're looking at. Things repeating, periodic functions, sine, cosine, tangent, they go over and over and over again because they come from that unit circle where you can go around and around and around and around and around and around she goes. Where she stopped, nobody knows, right? Onward and onward. Here's a massive table of values. It is crazily overly detailed here, but you can kind of see this is the unit circle, right? Here are my angles from 0 to 360. Okay, here are the sine values, right? And then the cosine values, right? And you can see that similar relationship where they match up, right? They are the same here on the 45, and then, oh, again, 135. Oh, because that's the 45 in the second quadrant, right? So I hope looking at this carefully, you can kind of see the unit circle picture coming together. But otherwise, ignore this table. It's just going to confuse you. It's not necessary. Here's what you need to know. The amplitude. Says it right here. The amplitude is how tall the graph is. Sort of. It's half of how tall the graph is, right? It is how stretched from 0, right? Amplitude is absolute value of half the difference between the maximum and minimum. Yeah, if you were given a graph and you had to calculate it, that's how you do it. But I would just call this, right? Vertical distance from, 0. I almost went through and made a theta there. Vertical distance from 0. Okay, and we can look at this very basic sine graph right here. Here is our 0. How high up does the graph go? It goes up to 1. So that distance right there is 1. Our amplitude is 1. Okay, how can you affect the amplitude? This is a vertical stretch. Okay, vertical. Maybe don't think of it vertical distance. Vertical stretch, just like any other graph. Multiply the entire function, and that will stretch it vertically. So if you create y equals 5 times sine of theta, then you're just going to make all of the y values 5 times bigger. You're going to stretch the whole thing up and down, and this will no longer be 1 high, it will be 5 high, right? This will go to 5, and it'll go all the way down to -5, okay? That's going to affect your amplitude. All right, next one. Is there a spot for period on here? No, because they introduced it in the previous sections. Okay, let's use the cosine graph to talk about the period then. What does the period of a trig function mean? That just means how long to repeat, right? When do you repeat? Okay? How long is your playlist until it loops back to the beginning? Cosine just so happens to start at 1. What value it starts with doesn't matter. But look at the value at 0. When do I get to that again? When does it go all the way through a full cycle and start all over? When have I gone all the way around the unit circle? Clearly, most cases, the default is 360 degrees or 2 pi radians. For some reason, the book goes back to defaulting most things with degrees here in this section. It's a little unfortunate, but that's what we have to deal with. So what if I wanted to stretch that? What if I wanted to expand that, make it longer, right? Well, now we're looking at, this is a horizontal stretch, right? Or shrink. And so we're going to clearly have to affect the x variable, the independent variable. In this case, it's theta instead of x because we're dealing with angles. So we want to multiply by the theta right there. So we're going to have y equals cosine of something times theta. Now I leave that blank there. Think back for a moment when you've been stretching other graphs horizontally. What happens if you want to make it wider, if you want to increase the actual width? Well, then you're going to have to work backwards. You want to undo it. How can I create the same effect of cosine of 360 degrees? But when I actually plug in a 720, right? If I want this to repeat at 720, then I need to make this not be 720, but be 360 when theta is 720. So I actually multiply by a half, right? It's going to be the opposite because we're dealing with the independent variable. You get the opposite effect. If you want to make it wider, you multiply by a smaller number. If you want to make it skinnier, you multiply by a big number. If I put 2 theta in there, it's going to smush it and it'll repeat at 180. Okay? So those are the numbers to watch out for. Where are those key points? How tall is it? Where does it repeat? All right, let's look at an example. How can I use this information to create my own graph? Very simple. Very simple. Amplitude, period. Yeah, there's all the algebra fancy bits. Write that down. That is good key stuff. Okay, but I'm giving you the super simple, quick and dirty version. Okay, find the amplitude and period of this function. Don't look at all that. Just read cosine 3 theta right there at the bottom. Okay, amplitude. Did I multiply the whole thing by a number? Well, in this case, no. It's still just a invisible 1 in front. So my amplitude is equal to 1. I didn't stretch it vertically by a thing. Okay. How about horizontally? Did I multiply the theta by something? Yes, we did. We have a times 3. Okay? So if we have a times 3, that means our period is going to be smaller, right? Theta got multiplied by a number bigger than 1, so the period is smaller. Default period is 360. Divide that by 3, and you're going to get down to 120. So this will repeat itself every 120 degrees instead. Okay? Simple rule, you can just divide 360 by the number there, because even if that number was 1/3, you divide 360 divided by 1/3, and you divide by a fraction, same as multiply reciprocal. You remember that bit. Okay? So we should see example here. They'll tell us first the amplitude, absolute value of A. Yeah, good, awesome. It's 1. Divide by 360 divided by 3, 120 degrees, right? How do we graph that? Don't even look at it. Don't look ahead. Whip up quick set of axes. Okay. How tall do we need to go on the y-axis? Our amplitude is 1. Okay. So if this is our y, this is our theta. The biggest number I need on here is 1. Smallest number is the opposite of that, -1. That's all I need. All right. How about in the x direction? Always include your 0. Okay. Don't have to label it. That's the origin. Include at least one full cycle. So the biggest number I need on the graph is that period, right? That's as far as I need to go, 120. Just mark that as 120 degrees, okay? And you definitely want half that. Always include half the period if you're making up the axes yourself. Obviously, I believe on the worksheet provided, they give you a set of axes to graph. It makes things really easy because it's almost like they're giving it away. If the numbers are right there, they're already drawn in for you. Just like pick the one that makes the most logical sense, okay? But do the calculation to be sure. All right, so I've got my period. I've got my halfway point. Next, we just need to determine what type of function is it, okay? Sine and cosine do the wave, right? Sine starts at 0, cosine starts at 1. Tangent does the funny S thing, okay? So that's a little bit trickier. But get your key points in there, and then it's just connecting the dots. Cosine starts at the maximum. Remember that. Cosine starts at the maximum. Sine starts at 0. So our starting point for our cosine graph is going to be our maximum. In this case, it's 1. We repeat at 120, so we get back to the maximum, right? And then, of course, halfway in between at the, I didn't actually label that. That should be 60 degrees. Okay, halfway between, we're going to hit our minimum. Okay, and if you really want to be persnickety, you might want to mark the quarter points as well, because that'll be, at least for cosine there, where it crosses the x-axis. That'll be the zeros, right? What values give you cosine equal to 0? And then we just come in and just real gentle curves, right? You know our shape is always going to be this thing with cosine. Curve down, curve bowl, bowl back up, and curve up and over, okay? Do it in 4 parts. It's simple. It might be crude, but it works. It gets the point across. Everybody will look at that and know that it's a cosine. Not a problem, okay? And then with some practice, then you can get fancy with it. Maybe do half at a time. That's usually what I do. Trying to do the whole thing in one fell swoop is just asking for trouble, because then I missed that bottom point there, right? Okay, that's all there is to it. That's it. Sine and cosine, piece of cake, right? Tangent's going to be a little bit trickier. Where do they have? They've got a tan graph around here somewhere, right? No, that's the secant. Okay, here's tangent. You still have the same things going on, right? Tangent defaults starts at 0. Okay, where does it repeat? Well, tangent actually has the double period, so it defaults repeats at the 180 already. Okay, halfway between that you get an asymptote, hence the vertical dashed lines there, right? So when you're dealing with tangent, you're going to want to find that period. Okay, in this case it is 180 by default every time. How does that change? And go one section more. So on your graph, create the 0 to 180 portion. Sorry, this black to be consistent. So create this much, find your halfway point, and go another half segment over. Okay, it'll just make it a cleaner looking picture, because no one wants to see just this bit. Okay, that doesn't tell us much. It's not quite enough to know for sure you mean that that is tangent, or that this just goes here and has horizontal asymptotes, right? See the difference there? So you got to get 2 S curves, okay? This is what you're looking for, minimum on graphing a tangent. Get 2 swoopy S curves there, okay? And that'll be enough to create a tangent graph. All right, there's tangent. You can go through secant and cosecant. Similar process to tangent. Get your period, get your asymptotes in there. Okay. If you want to, imagine there is the cosine or the sine graph going through. But I wouldn't do that much. I would just yeah, I would get start, I would get period, I would get my asymptotes. In this case, they're on the 1/4 and 3/4 mark. And then, yeah, treat it just like cosine as far as maximum points, minimum points. It's just a difference of what curves you draw in. You don't draw the sine cosine curve. You just go with u's. Okay. Secant and cosecant is the ooh graph of the algebra world. Okay. That's all there is to that. Doesn't have to be as pretty as the computer generated stuff. It's a quick sketch. Okay. This right here is top quality trig graph, okay? I would give that 1,000,000 out of 1,000,000 points every day, all day, okay? Doesn't have to look any better than that, because it's just a visual representation really to help you probably solve a little bit more complicated problem down the road, or just to communicate something else. Obviously, if you're making some kind of fancy presentation that you want it to look nice, you use the computer, okay? Quick sketch to answer questions. That's all you're after. And I think I've dragged this video out for as long as I can possibly get away with. There is nothing more to that. I hope you found this useful and helpful. I kind of covered the translations, not the translations, the stretches and such, the transformations, sorry is the general term, for section 2. We'll have a Desmos activity to cover that, so I won't have you go through the book, but you are welcome to read section 14.2 as well. You might find that the next section to be a little bit helpful in that regard, but I'm not going to make another separate video for it. It's just not a whole lot different from what I covered here. So with that, I'm going to leave you to it. So long, farewell, enjoy the rest of your day.